Welcome to the Neuroethics Learning Collaborative and to our final class, what I'm calling an introclusion to neuroethics. In the spirit of neologisms, compound neologisms like neuroethics, I've coined a new term, introclusion, which is meant to be a conclusion to the course, but also potentially an introduction. For those of you watching the videos on your computer, you may want to watch this first. In fact, if you really like it, you might want to watch it first and last. So what are we trying to do in this class? I have two goals. The first is to help you integrate the various lectures, discussions, readings, and so forth of the course into a coherent whole, a coherent understanding of the field of neuroethics. And the second goal is to help you continue your education and your involvement in neuroethics. So starting with the first goal, I'm going to situate the course material that we've covered so far in the broader geography of neuroethics. So here is some geography showing the Old World and the New World. Let me start with the Old World. So the field of bioethics, I hope the contrast in the letters there is good enough, but basically the field of bioethics has always included some topics that could be considered neuroethics that are neuroethics. For example, issues of safety for various kinds of experimental and clinical research tools, high field MRI, 7 Tesla and above, has various effects on the human body, and how safe is it? Who should decide? How safe is safe enough? These are questions that are sort of classic bioethical questions, and similarly TMS, which we heard about from Roy Hamilton. How safe is that? How do we know? Who gets to decide? Who gets to decide whether or not they're going to use it? Informed consent issues, basically. These are important issues that are not especially new. Bioethicists have been dealing with them, not in the context of the brain necessarily, but other organ systems, reproductive technologies, and so forth for a long time. Another important topic in neuroethics that has roots in classical bioethics is the question of incidental findings in research MRI. There's been a lot of discussion lately about what do you do when you're a cognitive neuroscience researcher. You bring an ostensibly normal subject into the lab to have them generate word lists or do scene perception or some sort of innocuous cognitive task, and there on your high resolution structural scan is a tumor or an AVM. What do you do? What are you obligated to do? What should the subject be entitled to assume you will do? This is something that John Detra talked about in one of the video blogs, the vlogs. It's a very important issue, but it is an issue that bioethics has lots of experience dealing with. You can have incidental findings for any organ system, right? Not just the brain. And so this is good news. This means there are helpful precedents out there for us to call upon. And finally, a very controversial issue in bioethics is research involving human embryonic stem cells. And of course, some of the diseases that show the most promise, or for which we believe stem cell therapies may have the most promise, are neurological diseases. And so here again, neural stem cell research raises neuroethical issues, but they are issues that bioethics is familiar with. Okay, and that's why I'm calling this the Old World. And we We definitely discussed some of these issues during this past semester, but the emphasis was not there. The emphasis is on what I'm calling the issues in the new world of neuroethics. These are ethical, legal, and social issues arising specifically because the brain is the organ of the mind. So interventions on the brain are interventions on the mind, on who we are. Okay? Imaging the brain, reading the brain, is potentially reading our thoughts. And this is, I would argue, qualitatively different from the kinds of privacy issues, for example, in terms of thought reading, that bioethicists are familiar with. So we have basically been emphasizing these issues here on the left. Yes, that's left. I want to say that unlike this map, which has, an ocean separating these two parts of neuroethics, the line is not that sharp between them. I don't want to make too big a deal of the distinction between the classical bioethical issues and the more novel neuroethical issues. Obviously, there are issues that we talked about in the lectures in this course that can draw heavily on bioethical precedents. And some of these issues that, I'm calling classical, maybe it sounds like I'm saying, oh, they're old hat. They're not old hat, they're important, and whenever new neuroscience is involved, there are new twists. So for example, with incidental findings in research scans, this was not an issue until cognitive neuroscience came along and psychology departments started getting their own scanners and citing them outside of medical schools, so that suddenly large numbers of people were getting their heads scanned outside of a medical context, sometimes with nobody on the team who's actually qualified to do a clinical reading of an MRI scan. And so that's a significant new twist, not just in terms of the number of people involved, but the sort of expertise involved to catch potentially serious health problems. Okay, so again, I think this distinction is useful, but I don't want to oversell it. It's not hard and fast, and I certainly don't want to leave you with the impression that I think, the new world issues are more important than the old world issues. But more as a sort of intellectual matter, I think there's more spade work, more groundwork that has to be done over here. And that's why we spent disproportionate amounts of time in this class on those issues. So let's look at these new issues and try to sort of map them out in relation to one another. I think what they all have in common is that they arise from the fact that neuroscience is giving us new ways to understand the brain and to monitor and manipulate the brain. So I'm going to try to sort of map the different topics that we've covered, and a few that we haven't, onto a tree structure, just for the sake of sort of making explicit some of the distinctions and sort of the relations among the different topics. And I think the first bifurcation is between issues of understanding, where it's not so much, we could do something, is it going to hurt people, is it going to help people, but more, what is this new insight from neuroscience tell us about ourselves as human beings? How does it change the way we think about ourselves, the way we think about our social institutions, right and wrong, and so forth? And then, of course, on the other side is the technology, by which I mean technologies for, because the alliteration here is nice, monitor and manipulate, I'm going to say technologies for monitoring brain function, monitoring and interpreting and reading brain function, and technologies for manipulating brain function. The technologies for manipulating brain function in turn break down to devices and drugs, sending molecules in to cross the blood-brain barrier and change brain function, versus various kinds of electronic gizmos from outside the head, non-invasive, TMS and TDCS, which Roy Hamilton talked to us about. And more invasive technologies like deep brain stimulation and brain chips that actually involve going in and implanting something. And let's see, I can't remember. Yeah, here the issues, here, as well as with drugs, the issues are very similar. They include what we talked about a few weeks ago, cognitive enhancement, personality enhancement, or if enhancement is too value-laden a word, personality manipulation, cognitive manipulation. Issues of regulation, should the FDA approve drugs for enhancement? Could that be an indication that the FDA would approve a drug for? What about device regulation? As you might remember from our discussion with John Mers and others in our panel discussion on regulation, the criteria for approving a device are different from the criteria for approving a drug. And is that a good thing, that the bar is lower? Do we worry that the burden of proof of efficacy is actually not very heavy for devices? When we're talking about devices to change brain function, especially devices, invasive ones, like deep brain stimulation or chips, or other kinds of vagus nerve stimulation, things that are somewhat invasive. What kinds of criteria ought we to have? And also a topic that sort of relates regulation and conflict of interest. What about the relationship between the drug companies or the device manufacturers on the one hand, and in this country the FDA? Is that a helpful relationship? Is that a relationship that encourages or discourages the best interests of patients and other users? So these are all neuroethical issues that we encountered in the course of the semester on the sort of manipulation of brain function branch, with all the really rapidly growing array of technologies for manipulating brain function. Okay, what about not affecting, but just manipulating, just monitoring the brain? Well, as we heard in Jeff Aguirre's lecture, there are a variety of ways to do this. Jeff mainly talked about fMRI. That is the most widely used imaging method in cognitive and affective neuroscience. But of course there are EEG methods and other blood flow based methods, and all have the potential to tell us something about human psychology, including mental states. By mental state, I want to distinguish it from a mental trait, which is a more enduring characteristic of a person. So with mental states, they're able to deliver information like the information that neuromarketers want, like, ooh, do I want that product? Or, ooh, does that advertising campaign really get my attention? Or, as the example that everyone loves to hate at this point, is that a political candidate that I have confidence in, that I would want to vote for? So clearly neuromarketing is in the business of trying to deliver information to people whose ultimate goal is to manipulate us, right? To get us to vote for their candidate or buy their toothpaste or whatever. And it relies on technologies for monitoring the brain. Lie detection is another much discussed example of brain reading in cognitive neuroscience. And as we discussed, it's not clear that the methods now available are really up to the task of delivering reliable information about somebody's truthfulness in real world contexts, right? How well they perform in a laboratory task when, the lie is about what card you're holding, a deck of playing cards, does not necessarily predict how well it's going to work in the real world. I hasten to add, maybe it would work better in the real world, right? I mean, we just don't know. It's not just, of course the real world is harder. My hunch is that it is, but the point is we just don't have the information about brain-based lie detection and its effectiveness in real-world contexts. So the kinds of pattern classification techniques that Jeff told you all about, using reverse inference in more valid ways, less valid ways, these are all the issues that come up with monitoring mental states. Okay. Now, continuing to grow our tree, we have another branch here, which I'm calling brainotyping. This is basically the use of brain imaging to get trait information about people. What kind of person are you? Okay, it's kind of like a high-tech sorting hat from Hogwarts. Brainotyping is supposed to be analogous to genotyping, right? Which again, genetic information doesn't say what state you're in now or what, how healthy you are this year as opposed to last year or next year. It's a much more enduring kind of trait information. And likewise, brain imaging has been found to deliver some, reasonably predictive information about traits, about psychological traits, be they intelligence, personality, or to take an example from Adrian Rain's talk, criminality or potential dangerousness. Now, again, I hasten to add that, I said it delivers not bad information. It delivers information that is impressive from the point of view of basic science, right? 10 years ago, I think most knowledgeable people would have said, you're never going to be able to get any kind of correlation with a personality trait like extroversion or an attitude like racial bias by just putting somebody in an fMRI protocol. And now we know that you can get reasonably good correlations. Certainly for social science, they're actually pretty astonishing correlations. In the sort of 0.5 plus or minus. That's really, really good for social science. But of course, they're not high enough that you could use this as a measurement instrument yet. But obviously, we're making progress and we're going in that direction. So this again is a neuroethical issue. How much can we find out about you by sticking you in a scanner? And of course, when you're in the scanner, you don't know necessarily what information is being read out, right? I mean, I can just say, step into my scanner, look at these pictures of, various faces of people you don't know, and I could lie to you and say, this is an experiment about face perception and face memory. And of course, what I'm really doing is varying the race of the subjects and keeping track of your amygdala response to the different faces as a function of their race. And as a number of research studies have now shown, that differential between the amygdala reaction to same race and other race faces correlates, again, not bad, 0.5 plus or minus, with racial attitudes measured by other means. So it's not just that these methods can deliver information, but they can deliver information about things that the subject isn't even necessarily aware are being studied. Okay, let's now go over to the other side of the tree, which is just the effects of, the sheer understanding of ourselves as brains. So for a lot of purposes in life, we think of ourselves as persons. That is, I think Stephen Morse reviewed some of this in his lecture. Persons act for reasons, not causes. So, if I pick up my phone and drop it, its descent is caused by gravity. If I, reach up and scratch my head, that's not caused. That I scratched my head for a reason. It felt itchy. I knew that if I put my hand up here and did a little of that, my scalp would be more comfortable. So this is one of the most fundamental differences between things and persons, that things behave, if you will, because of causes, and people behave for reasons. And of course, there are many, or persons, to use the way philosophers talk. There are lots of other sort of correlated differences between things and persons. Persons have rights. Persons have moral responsibility. I don't blame my phone if it doesn't work, if it drops a call or something. I don't go, bad phone. But if a person does something wrong, I don't say, oh, Irena malfunctioned. She didn't get her 699 paper in on time. I say, Irena was irresponsible, whatever. So I attribute a certain responsibility to her to get things done. So this is these are all highly correlated, characteristics of what we think a person is. And in general, I think you can say much, if not all, of the challenges that neuroscience poses for us in neuroethics come down, at root to the fact that when we are understanding ourselves as brains, when we are treating ourselves or each other as brains rather than persons, when we're understanding ourselves as brains or treating somebody as a brain, we are treating them as a thing, not as a person. And sort of how to live our lives and sort of continue as a society, maintaining this kind of duality between seeing humans as persons and things is the challenge that neuroethics grapples with. In Stephen Morse's, let me put that off for a minute and talk about these borderline cases. So I think that the most familiar kinds of challenges that that neuroscience understanding poses, the ones that we talk about the most, have to do with trying to figure out who is a person, and who or what is a person, and who or what is not. Okay, so So, for example, let's talk about like immature brains, the brains of fetuses. You know, if we think of being a person as having a brain that is capable of conscious thought, of feeling, of self-awareness, well, in some sense, a fetus is not a person. In fact, babies are not persons. And you know, what do you do about that? Well, I think one thing to do about that is to say, well, they may not be a person now, but barring some, you know, sort of brutal intervention, they will eventually become a person. So maybe we can justify respecting their rights as persons on the basis of their potential. But then what happens when we talk about severely brain damaged humans, somebody with advanced Alzheimer's disease, or somebody like the patients that Adrian Owen studies? Adrian gave a talk here a couple of days ago on patients in vegetative states. These are patients like Terry Schiavo. Their brains are severely damaged, and yet they're living, breathing human beings. Are they persons? Because what's kind of mind-boggling, but again, classical bioethics has dealt with these issues for a while, is that you can be a human being and not be a person. If you're brain dead, okay, you are a human being, even though you might be warm to the touch and have good color and all that, but they can take your organs, right? You are legally dead, and within most religions, you are dead. Somebody who's in a vegetative state is not legally dead, so it's a little more difficult to know, you know, how we should treat them. They are sort of on the borderline between being a person and not being a person. And we didn't talk about this in this class, but there is, you know, much interesting work on this and many interesting discussions to be had about what insights neuroscience might give us into the personhood of, say, a vegetative patient. And some of the interesting work that, for example, Adrian Owen spoke to us about a couple of days ago shows that if you image these people, if you do functional imaging of these people, even though they are quite unresponsive, they show brain activity indicative of having a mental life. You can say to a patient, as he has, now I want you to imagine that you're playing tennis. And what you see is the supplementary motor area lights up, just as it does in normal, healthy subjects who are imagining playing tennis. And then if you say, now I want you to imagine walking through the rooms of your house and looking around and, you know, making note of the environment, well then the parahippocampal place area, which I think Teresa studies, lights up just as it does in normal people. So there's somebody home, right, which we didn't know until brain imaging came along. And so, you know, on the one hand, it's kind of opened up a whole can of worms about what to do with these kind of borderline cases. On the other hand, you know, it may ultimately save some individuals from, you know, being treated, you know, custodially and not as persons. Non-human animals. So not only is not every human a person, but maybe not every person is a human. So some animal rights activists have taken the legal tack of trying to get legal personhood for animals, so that the animals will then enjoy the rights of persons. And I mean, I believe in Spain, I should have checked this before I came to class, but I'm pretty sure in Spain they are legally persons. And that has, of course, made for difficulty doing certain kinds of research on them, because although they're persons, they can't give informed consent. But in any case, there's a whole huge array of tough cases here, these borderline cases. It's easy to look at you and say, I know you're a person, but what about some of these people that aren't some of these cases that aren't so prototypical? It's ethically very important to know who's a person. Maybe even some kind of advanced artificial intelligence. We might, the HAL in 2001: A Space Odyssey, but maybe that's not always going to be just science fiction. I mean, we don't know. That person wouldn't have a biological brain at all. Okay, in addition, there are issues concerning persons like we have here, okay? Persons of whom it's easy to say, yeah, this is a person, and therefore deserves, moral consideration. I can't just say, she's malfunctioning, let's, throw her in the dumpster, right? What are the issues here? Many issues that we have talked about, starting with responsibility. Again, we attribute moral responsibility to persons. They have moral agency. We expect them to choose the right thing, and if they don't choose to do the right thing, we blame them. And yet, if neuroscience's view of human beings is right, it makes no more sense to blame a person for doing something bad or failing to live up to their promise or whatever than it does to blame a thing. There's actually a great John Cleese skit on YouTube from some, I don't know if it was Faulty Towers, some old British sitcom, where he gets mad at his car and he gets out and he starts punishing it and hitting it and yelling at it and scolding it. And it sort of brings out the absurdity, right, of taking a sort of person stance towards a physical device, and yet, what more are we? I would say that neuroscience is asking us than a really complex, really impressive physical device. So Stephen Morse, of course, took great pains to make the argument that these two views of human beings as persons and as sort of biophysical devices are not incompatible. He is what's known as a compatibilist in the debate about free will and determinism. Not everybody is convinced by that point of view, but it's an open issue. How do we come to terms with this, and not just say, well, we can close all the courts of law because there's no point in blaming anybody because ever since the Big Bang, it's all been predetermined and we're just physical mechanisms carrying out what we had to carry out by the laws of physics. Okay, so that I guess that sort of captures responsibility and morality, although actually it's worth mentioning another topic that we have not so far covered in this course, but maybe next year we'll add some lectures on it, is the neuroscience of ethics. So sometimes people say neuroethics is the ethics of neuroscience, which is what we've been talking about, and the neuroscience of ethics. In other words, understanding the neural systems that underlie human judgments of right and wrong. And one of the best known contributors to this area is Josh Green at Harvard. And he has shown, that there are different brain systems involved in deciding what's right and what's wrong. Interestingly, harking back to Autumn Feaster's early lectures, there's an essentially utilitarian system, which, not surprisingly, engages a lot of dorsolateral prefrontal cortex, parietal lobe, all the sort of cognitive, working memory, calculating, problem-solving areas. And there's also kind of a Kantian deontological system that tends to activate more affective areas and tends to sort of come online, in just those circumstances when you just kind of think, oh no, that would just be so wrong. When you have that sort of emotional gut feeling, no, that's wrong. And of course, for most of us, they're both operating and generally come to the same conclusion. Sometimes the situation is such that, the utilitarian calculation points you in one direction, the deontological points you in another, and then you're really in conflict. But when we think of the things that we most admire, that we most value in a person, they are things like, sort of moral character, understanding and caring about the difference between right and wrong, love, our capacity to, to love each other and be selfless and, altruistic, our sense of spirituality, which, is one of those words I've asked many people what that word means, and it's hard to get much of an answer, but the sense of something that matters, that transcends the kind of here and now and the material concerns that we have. All of these things which we so highly value and that seem to be such important kind of core features of what makes a person a person, in every case we have neuroscience research showing us the mechanics, showing us the nuts and bolts and the gears turning, and love is a little bit of oxytocin, maybe a little vasopressin if you're a guy. It's dopamine when you're sort of in that head over heels in love phase. It's the fact that this all comes down to biology, even spirituality, as our colleague Andy Newberg has shown, imaging meditating monks and praying nuns, he finds that there is a characteristic pattern of brain activation that accompanies this state of sort of experienced, transcendence. It really seems like there isn't much of anything to a person that can't just be explained in physical terms. And I think the challenge is not not lapsing into a kind of nihilism, not saying, well, it's just all physical stuff, a mother's love for her child, a brave soldier's love for his country. It's just a bunch of chemicals, going between neurons in a synapse. Who cares? So again, neuroscience, I think, challenges us just, at the understanding level to sort of maintain the meaning of life, actually. Even this idea of a soul, of an immaterial soul, well, we're explaining an awful lot of what humans do and what humans experience in terms of physiology. Is there anything left over to attribute to an immaterial soul? I mean, you might have thought it was love and moral character and stuff, but it looks like we can explain those too in terms of the brain. So is this a threat to the many religions that hold that there is an immaterial part of a person? It could be. Now, I'll add that the existence of an immaterial soul is a less central part of many religions, at least historically, than I think most people realize. There's a wonderful theologian at the Fuller Theological Seminary, Nancy Murphy, who has written about the earliest parts of the Christian Bible and the Hebrew Bible actually have a lot of materialist, physicalist, mind-brain philosophy in them. It may not. It's not necessarily the case, according to Nancy Murphy, that to be a Christian you must believe in a soul. Certainly, there are Christians who do, and certainly there is support for that view in Scripture. But Scripture is a concatenation of many different sources, and it's not consistent on that matter. So basically, all of the core features of personhood, including the idea of a soul, are, I don't want to overstate it. They're not disproven, but they are. They have to be reinterpreted, I think, in the light of modern neuroscience. Okay, so let me just see where we are. Oh my God. Time to. Okay, so two more quick things about the relationships among these different topics, because really what I'm trying to do here is show how the different topics of the lectures and the readings and so forth fit together. One thing is that by graphing it as a tree, I've tried to sort of emphasize distinctions that we want to keep clear on, but also capture a certain distance metric or similarity metric that has to do with, the more close these topics are to one another in terms of path length, right? The more related they are, the more similar they are. But this doesn't capture all the cross-cutting similarities and relationships. And I want, the topics in red here are basically subject matter problems, raised by neuroscience, but they aren't sort of the neuroethical issues themselves. So what I want to do is quickly just review some cross-cutting issues here, and kind of talk about how they relate and sort of link different neuroethics topics. Safety I'm not going to talk about. It's obviously extremely important, but it's also fairly cut and dried in terms of how to analyze it, how to assess it. We know how to do that. We don't always do it, but there's no real kind of nuance or complexity, I don't think, there. So let's talk about privacy next. And let's just go back to this tree. So privacy. Obviously, it comes up here with sort of mind reading mental states, brainotyping. Here, yeah, which thanks. When Jeff Aguirre talked about reverse inference and pattern classifiers, he was, telling us about these rapidly developing methods that are giving more and more information about people, some of which you might not just want anybody to know. So, the issue of, are you entitled to privacy about your thoughts, attitudes, etc.? Most people would say yeah. And then in that case, how should we protect that privacy is an important neuroethical issue. Privacy also has a meaning in the law that has to do with just your ability to control your own body and mind, and kind of mind your own business and not have other people interfering, and that of course arises here with, let's say, your freedom to enhance if you want to enhance, or yeah. Just your ability to engage in enhancement, which with at least some medications is currently not legal, and that raises other issues. So privacy is one thing. Another thing that was on the list, I'm not going to keep switching back and forth, but is autonomy and freedom. And that again comes up here. Should I have the freedom to, do transcranial direct current stimulation on myself? This is something that Roy Hamilton talked about, and he mentioned that it does not require a lot of fancy instrumentation, right? It's a 9-volt battery and some wires and a couple of cotton balls soaked in saline. So people can do this at home, and some are. There is a certain amount of chatter on the web with people saying, oh, now I put the anode over my left prefrontal, but I didn't really feel much of anything, So, well, should people be free to do that? How much should we be stepping in and trying to regulate these things? And is there any point to trying to regulate them? Because, is it even enforceable? I mean, it's one thing to try to control drugs. They have sources and, a sort of, business that you could conceivably intervene in. But what people do in the privacy of their own home with a 9-volt battery is a little hard to control. So there's also autonomy or freedom issues in the realm of enhancement that come up when somebody doesn't want to enhance and is either being ordered to, perhaps you're a long-haul truck driver or airline pilot, or perhaps you're a surgeon on night call. Are we going to see the day when your boss is going to say, if you want to do this job, you have to be willing to take some wakefulness enhancer to ensure the best possible performance under conditions of stress and fatigue? Actually, I was at a fun meeting a few weeks ago where we were all asked to come up with a prediction for, I think it was the year 2015. And my prediction was that in 2015, we will see the first legislation concerning, either freedom to enhance or more likely freedom to not enhance. Because, to the extent that there are medications that will make a surgeon better able to operate all night long, or make a pilot, safer to land a plane after flying for 20 hours, or, there's a rationale for asking them to take this medication. So there can be overt demands to enhance, but there are also kind of indirect, covert forms of coercion. So, if you're working in an office where almost everybody is using cognitive enhancement, you may look like a slacker because you're not enhancing. So you're going to be under a certain amount of pressure, even though nobody's coming out and saying, we want you to do this, right, to enhance. So again, freedom, autonomy, this is an issue that cuts across a lot of these things. It cuts across these. Also, clearly, here, if we have a profile of brain activation that is highly predictive of criminal behavior, which of course we don't have at this point, but when and if we do, what about the rights of those people to be free? I mean, would it make more sense to protect society and detain them preemptively, or at least, keep them on a very short leash, checking in with the equivalent of a parole officer? So there are a lot of ways in which these new neurotechnologies, raise new issues about freedom and autonomy. Right now, we don't have any fantastic, really effective, safe cognitive enhancers, and we don't have any brain imaging protocol that can tell you with great certainty that somebody's going to go out and commit a murder. So now, I think maybe the most immediate neuroethical issue is premature adoption. How do we prevent, or what do we do about the fact that these techniques have this great aura of objective science, right? Well, if somebody is running a neuromarketing operation and gets Colgate-Palmolive or something, to contract with them to do neuromarketing on toothpaste, what's the worst that happens? They waste some money. But if the government decides to use brain-based lie detection or brain-based screening of personality or criminality or, potential for being a terrorist or whatever, thinking, hoping, perhaps with a certain amount of wishful thinking, that it is a helpful indicator, much worse consequences could follow than merely some company wasting money, right? So, so I think premature adoption right now for all of these technologies is clearly the biggest concern. And finally, I think a big cross-cutting issue is what I've called the person-thing clash. And I've already talked, at some length about issues here and here. The problem is that, again, neuroscience is giving us a view of ourselves as fundamentally things. And even over here, I think some of the issues that arise with these technologies touch on this person-thing clash. For example, one reason people find it objectionable to enhance oneself with drugs or TMS is that it's somehow treating yourself like an object. So, it's one thing to try to do better in school by studying harder, by getting a teacher and having, kind of collaborating with another person to try to achieve more. There's something about popping a cognitive enhancer to do better in school that's a little bit like treating yourself like a car, where you want to get better performance by adding some additive to the gas tank, right? It could be viewed as kind of dehumanizing or depersonalizing, and I think there's something to that. and I think that the more we do this sort of thing, I mean, even the growing use of drugs and devices for therapy, let alone enhancement, but certainly enhancement makes it more so, tends to kind of soften us up, or you know, to the way of looking at ourselves as physical entities, so I think this person-thing clash, as I said, my feeling is it really lies at the root of just about all of the neuroethical issues that we've talked about in this class, and it's a cross-cutting issue that links most of that tree. I am going to go really quickly to ways in which you can engage with neuroethics in the future. So first of all, you know, it's a hot topic. People are writing about it. There are lots of books out, including, you must all watch the MIT Press website. In July, I expect that Neuroethics and Introduction with Readings will be out. In the meantime, there are these many other excellent books and others that I didn't put up here that will give you lots of good reading. And there are also 2 journals that are specifically dedicated to neuroethics. There's the American Journal of Bioethics /Neuroscience or -Neuroscience, and there's a journal called Neuroethics. You know, every few months they come out with a new set of interesting articles on the kinds of things that we've been discussing. In addition, I want to introduce you to the Penn website. Our goal for this website was obviously to give people certain information about Penn, people at Penn, events at Penn, but we also wanted it to be a resource for everybody on the subject of neuroethics. And so, just to show you a few things, we have a neuroethics calendar that has events at places other than Penn, like UNC Charlotte is having a symposium on neuroaesthetics and neuroethics in a few days. That is also, okay, the Worldwide Neuroethics Calendar, which has every neuroethics-related event that we've been able to get wind of posted here with links where you can find out more. And if you have neuroethics events that you know about because you're going to them or you're putting them on yourself, please email us and let us know because we'd like to put it on the calendar. The Resource Center has various things, including course syllabi. So if you want to find out what people are doing in other courses, maybe teach a course yourself, get some ideas for, here's a Introduction to Neuroethics taught at Hiram College. You can see, you can get the syllabus right here. And I'm pleased to say there's a lot of courses now in this field. Finally, I want to call your attention to what we call on here the Penn Neuroethics Briefing. And this, in terms of a place to go to read more about neuroethics, is, I hope, will be helpful. We have a little briefing, the equivalent of a page or 2, and then reference articles, which are an assortment of scholarly articles, not so much from the popular press, although the occasional good, New Yorker magazine article we include, with links to the Medline page for each of those readings. So I hope that that'll also be a place that you can get some useful information on neuroethics. Okay, let's go back to our presentation. The last thing I want to tell you about is the Neuroethics Society, which, from current slide, which is an international group of professionals and students interested in neuroethics. It was founded in 2006. We've had one meeting so far. We took, I guess we had a meeting in 2008. We took 2009 off. The next one is 2010 at the Society for Neuroscience. We did that so that there would be less of a travel burden on people who were attending SFN anyway, and because we were really committed to having neuroscientists involved in the Neuroethics Society. We also really want bioethicists, philosophers, and so forth, but we felt that without good science representation, we wouldn't be serving the field of neuroethics as well. There's the URL, so you can go on, you can join. If you're a student, it only costs $30 a year to join. That puts you in touch with members from around the world. It gets you a bi-monthly newsletter, as well as the opportunity to come to the meetings. So I hope you will continue learning about neuroethics and consider this not the end of your neuroethics education, but the first step. And I thank you very much.